This section, we are going to define what electric current is. So electric current is very important because all electrical devices, lights, radios, television sets, air conditioners, refrigerators, all are using electric current as electrical energy source. So electric current not only exists in the devices, also in human body there's an electric current. The human heart is working with electric current, small electric current in your body. So electric current exists whenever there is a net movement of electric charge through a medium. So when we say electric charge, you understand electric charge can be both positive and negative. Negative one is electrons. Electrons are negatively charged particles. Positive charge, protons. So these can carry electric current, but not only this. For example, negative ions, atoms which negatively charged atoms are called ions. Positive ions, they can also carry electric current. Also, you are going to study in the 11th class some other charge carriers are also possible. You are going to study them in the 11th and the 12th grade. So to define current more precisely, suppose electrons are moving through a conductor as shown in the figure. Now, these are electrons, negatively charged particles. Remember, in conductors, electrons are free to move. They can move from one side to other side in the opposite direction of the electric field. So electric field is in that direction, electrons move in the opposite direction. So the electric current is defined as the rate at which these charges move through the cross-section area of a wire. So you are going to choose an area right here. So you are going to count how much charge passes through this area in a unit time. So when it says the rate, you will understand you are going to divide a physical quantity by time. So the rate at which charges move means, so you are going to calculate delta Q divided by delta T. What is delta Q? Charge passing through this cross-section area of the conductor. What is delta T? The time it takes for this charge to pass through this cross-section area. And then electric current is delta Q over delta T. So delta Q is charge, unit of charge is coulomb. Delta T is time, unit of time is second. So electric current has a unit of coulomb per second, which is known as ampere. So 1 ampere is the unit of electric current, is equal to 1 coulomb per second. So if delta Q is the amount of charge that passes through this area in interval delta T, then the current I is the ratio of the amount of charge to the time interval. Yes, it is the ratio of the amount of the charge passing through this cross-section area in a period of the time. So you can calculate the electric current. As I said, electric current unit is ampere, which is equal to 1 coulomb per second. So sample problem in your book, it says that the current in a light bulb is 0.835 ampere. So electric current, symbol of electric current is I, unit is A, ampere. So I is equal to 0.835 ampere. How long? When it says how long, it's asking about the time, delta T. Does it take for the total charge, delta Q, 1.67 coulomb to pass through the filament of the bulb? So in the bulb, we are going to calculate how long does it take to pass through this amount of charge. So equation for calculating electric current is that I is equal to delta Q over delta T. But the question is to calculate delta T. Cross multiply them. So simply exchange their positions. Take delta T here, take Q I there. Delta T is equal to delta Q divided by I. Delta Q is 1.67 coulomb. Del I is 0.835, so time is 2 seconds. It takes 2 seconds to pass the 1.67 coulomb charge through this filament of the bulb. Now, the moving charges that make up of current can be both positive and negative. So as I explained, positive is, it can be positive ion or it can be proton. Negative can be negative ion or it can be electron. So, or both, all combination of the two. Yani in electric current, charge carriers can be positive or negative or both of them. So, like in the solution, in chemistry, you studied. In a conductor such as copper, aluminum, gold, silver, current is due to the motion of electrons. Yes, in conductors. In general, these are metals. Copper, the current is due to the motion of electrons. Electrons are moving because electrons are free to move in a conductor. Because the atomic structure of the solid conductors allows electrons to be transferred from one atom to the another one. In some gases, in some cases, for example, in gases or some fluids, which is known plasma, current is the result of positive charge moving in one direction and negative charge moving in opposite direction. So ions are moving. So if ions, positive ions moves, for example, to right, negative ions will move to left. Positive ions will move in the direction of the electric field, but negative ion will move in the opposite direction of electric field. Positive and negative charges in motion are sometimes called charge carriers. Know this term, charge carrier. So chapter 9 in physics, 12th grade physics, charge carrier, you are going to meet this. So conventional current, what does convention mean? Direction of the electric current is defined in terms of the flow of positive charge. So electric current, in fact, is defined in terms of the flow of positive charge, which means the negative charge carriers, such as electrons, would have a conventional current in the direction of opposite of their physical motion. In physics, electric current is defined before the electrons. For that reason, electric current direction was given before electron is discovered. But later, the electrons are moving in the opposite direction of the decided electric current. For that reason, if the charge carries electron, if the charge carries electron, and if it is moving to left, we say that electric current because of that charge carrier is right. So conventional current is right. If the charge carrier is positive charge, like proton or positive ion, so electric current direction will be the same as the direction of the motion of the positive charge. But if charge carriers are both of them, positive and negative, so possible? Yes, possible. In this case, electric current direction will be in the direction of the positive charges. So, in general, electric current direction is assumed to be the direction of the motion of positive charges and in the opposite direction of the motion of negative charges. Alright. Now, we know what current is and how it moves and how can we calculate electric current passing through the conductor. We defined this. Now, is it so difficult for electrons to move through a conductor? It's not so easy to move. So there's some difficulty to the flow of electric current inside a conductor. Electrons are free to move, but while these electrons are moving through the conductor, electrons collide with the atoms. It is similar to this. For example, there's a playground and then there are so many students are playing and you are running from one end side of the playground to other side. So then while you are running, you are colliding with other students playing or standing or running in the field. So electric current also like this. Electrons are moving from one end of the conductor to other end, but while they are moving, they are continuously colliding with atoms or other particles inside the material. This collision results resistance. So then this resistance or this collision makes electron motion difficult. So then the resistance is defined such so that the opposition to the motion of charge through a conductor is defined as that conductor's resistance. So this definition is very important. Don't forget the opposition I mean, when I was talking about this, I'm talking about the 12th grade. This is very important for 12th grade. The opposition, you are going to meet this term. The opposition to the motion of the charge through a conductor is conductor's resistance. So while electrons are moving through this conductor, they don't move straight path. They are colliding continuously, for that as in change in direction. So electrons do not move in a straight line path through a conductor. Instead, they undergo repeated collisions with atoms. These collisions affect the motion of charges. This is the origin of material resistance. What is the origin of resistance? Collisions between the electrons and atoms. But what determines what increases the resistance, what decreases resistance? Assume that the playground is very long playground. You are running and continuously you are colliding with other students, and you are going to lose your energy. So it will be much more difficult for you to move through the playground. It is similar. If you make the conductor longer, in this case, electrons will collide with more atoms while they are traveling. So then if you make the viral conductor longer, resistance increases. If you make the conductor shorter, resistance decreases. So less resistance, less length, greater resistance, greater length. Second thing is cross-section area. So assume that there is a door in your classroom. So then everybody wants to go out at an instant, but door is very small in area. But if you use a very large door, if a very big door, so then so many students can quickly pass through this door. It is similar. If you use a thicker wire, so resistance becomes smaller, so electrons can move easily. But if you use a thinner wire, so resistance becomes greater because electrons move, motion of the electrons become more difficult. So then in general we can say that resistance is proportional to length of the conductor. So greater length, greater resistance, but resistance is inversely proportional to cross-section area. Area if we represent by A, cross-section area of the conductor. As cross-section area decreases, resistance increases. As cross-section area increases, resistance decreases. A third factor which affects the resistance is type of the conductor. This is not given in your book, but it's important. So type of the conductor means, for example, silver is the best conductor. Silver. Next one is the copper. Copper is the second best conductor. Right after is coming the gold. Gold is not the best conductor, so it is the third one. So right after coming aluminum. So as you see, resistance also depends on the type of the material or conductor. These three factors determines the resistance of a conductor. But another factor is temperature. When you heat a material, this is also related to 9th chapter of 12th grade. When you heat the material, atoms are vibrating. Normally, atoms are not at rest inside a conductor. They are vibrating. So when you heat them, they start to vibrate with the greater distance and collides with electron more frequently. That makes the resistance greater. So then heating a substance, especially conductors, make resistance bigger. So now we know what resistance of a conductor depends on what. It depends on the length, it depends on the area, it depends on the type of the conductor. In fact, there's an equation. This equation is not given in the 12th 11th grade book. This equation is very simple. Resistance is equal to rho times L over A. What is rho? It is called resistivity. It depends on the type of the material. What is L? Length of the conductor. What is A? Area of the cross-section area of the conductor. So this is the factors which determines the resistance. But how can we measure this resistance? How can we determine this resistance? We can determine the resistance by using Ohm's law. Don't forget Ohm's law. This is very important for 12th grade too. Ohm's law says that if you measure the potential difference across the end of a conductor, for example, how can you measure the potential difference across the end of a conductor? So assume that on this conductor there's an electric current. You can measure the potential difference by using voltmeter. voltmeter measures the potential difference. But if you put an ammeter on right here, so by ammeter you can measure the electric current. If potential difference is measured by a voltmeter, if electric current is through the wire is measured by an ammeter, you can calculate the resistance. How? By dividing potential difference to electric current. R is the resistance, delta V over I. This is one of the most important equations in physics, which relates resistance of a conductor with potential difference between the ends of this conductor divided by electric current passing through this conductor. So unit of resistance is ohm, and generally symbol of it's symbolized by omega, this symbol. And 1 ohm, according to this equation, 1 ohm is equal to 1, what is the unit of potential difference? Volt. 1 volt divided by what is the unit of electric current? Ampere. So 1 volt per ampere is equal to 1 ohm. However, every substance does not obey the Ohm's law. If a substance or conductor obeys Ohm's law, yani if the electric current and potential difference changes proportionally according to this equation. So if you increase the electric current, potential difference increases. So to keep the electric resistance constant, then we say that this substance is ohmic, which means it obeys the Ohm's law. Then in this case, if you draw the graph, which is the current potential difference graph of this substance, you are going to get a straight line. This straight line says that this substance is an ohmic substance, or obey Ohm's law. But if you observe electric and potential difference are not changing proportionally, if it is not a straight line, if it is a curve as you see here, this is non-linear. This is linear graph, so it obeys the Ohm's law, so it is ohmic resistance. But this is not a straight line, it's a curve. As you see, it is not linear. If it is not straight line, it is not linear, non-linear. So reason is what? Because this substance, whatever it is, does not obey Ohm's law. So this is not a ohmic resistance. It is known as non-ohmic substance. So resistance is this, but resistance is general measurement. But there are some devices which is specially produced to make a resistance. They are called resistors. So resistance is the phenomenon which we observe opposition to the electric current, but resistor is the device. This device is a resistor. So a group of resistors in a circuit is shown here. Why do we use the resistors? Because sometimes we need low current, sometimes we need high current. If we need low current, we connect more resistors in the circuit and we decrease the electric current. For example, if you don't want to get the shock or the great electric current and you want to decrease the danger of electric current, you can connect more resistors one after another and you can decrease the electric current and then make electric current less dangerous. Okay, about Ohm's law, there are so many questions in your book. Just one or two, let's solve them. They are very easy. For example, it says 1.5 volt battery. It is delta V. It's connected across a small light bulb with a resistance R. So what is the current in the bulb? So remember, R is equal to delta V over I. So questions calculate delta, calculate the R, cross multiply them. I is equal to delta V over R. So then delta V is 1.5, R is 3.5, divide them and get the result as ampere. So questions are generally easy for that, as I'm just going to pass them about the Ohm's law. But don't forget, Ohm's law is very important, especially for 12th grade physics. Now power. So when you drop a ball, these sentences are from your book and very good sentences, I like them very much. It falls to the ground, moving from one place of higher gravitational potential energy to low one that lower gravitational potential energy. So when I release this pen, it falls down from a point of high gravitational potential energy to a low potential energy. So in this case, energy, potential energy decreases, but this potential energy converts to other types of energies. So in physics, in science, energy is not lost, only converted from one type to another. But charges also behave the similar way. As charge carriers move from higher to lower electric potential energy, this energy difference, yani decrease in potential energy, converted to internal energy. What is internal energy? Internal energy is the energy, total energy of particles or atoms, molecules, which is inside that substance. So this internal energy emerges from the collisions between the moving charges and remaining material. As I said, electrons are moving through the conductor. While these electrons are moving, they're continuously colliding with other atoms. And because of the collisions, they lose their energy. This energy's loss appears as internal energy. So this internal energy, if increases number, then it will be given out as terminal energy, or in other words, heat. That's why when you hold your hand across a heater, you feel it. Where does this energy come from? This energy is coming from the energy of the charge carriers, which are electrons. Electrons, while they are moving through the wire, they collide with other atoms and loses their energy. This lost energy appears as heat. So in physics, there are two types of electric current. One of them is the direct current, which is the current of a battery, for example. So this current does not change as time passes. But there's one more current we are going to set in 12th grade, which is alternating current. In alternating current, direction of the current continuously changes. One positive, one negative. One positive, one negative. One right, one left. One right, one left. In direct current, electrons are moving in one direction from one side to another. But in AC, electrons are not moving in one direction. They are moving back and forth like this, going back and forth. On the same place, they are like dancing, back, forth, back, forth, back, forth. In AC, they are moving in this way. Next step is to define the power. What power is? When a battery is used to maintain an electric current in a conductor, chemical energy inside the battery, stored inside the battery, is continuously converted to electrical energy of charge carriers. So, chemical energy from battery is given to the charge carrier as electrical energy. As the charge carrier moves through the conductor, this electrical energy is converted to internal energy due to collisions between the charge carriers and other particles of the conductor. I defined this before. So, electric power is defined as, again, the rate. You will meet it so many times, rate. When there's a term rate, understand that a physical quantity is divided by time. So, electric power is the rate at which charge carriers do work. Another way, in other words, electric power is the rate at which charge carrier converts their electric potential energy to non-electric forms. What is these forms? Heat, light, sound, etc. So while electrons are moving through the conductor, or a device, they lose their electric potential energy, and this energy appears as other types of energy such as heat, light, and sound. So how fast this energy is converted, or how great is this conversion, it is the electric power of that system is big. So now I'm going to get the equation for electric power. What is that equation? If some charge Q is carried by electric field between 2 points of the potential difference delta V, the change in the electric potential energy of the charge can be given by this equation. Remember, I give this equation in section 2. Delta V is equal to change in electric potential energy divided by carried charge. If you cross multiply them, you'll get this. So decrease in electric potential energy is equal to charge carried charge multiplied by potential difference between the points which charge is carried. Because power is the rate at which electric energy is converted to other types of energies, so power can be defined by rate delta T, at which electrical energy, electric potential energy is converted to other types of energy. And delta EP divided by delta T is the power. Delta EP, we said that QO times delta V, QO times delta V. And we know that Q divided by T is electric current. Remember, we defined this. So then you got the equation for power. Power is equal to electric current passing through a device. Let's say that power of a device is equal to electric current passing through this device and potential difference across the terminal or end of this device. So P is equal to I times V, another most important equation of physics. Power is the rate of conversion of electrical energy to heat or to sound or to light. Recall SI unit of the power is watt. You studied in chapter 4. SI unit of the power is watt and W. In terms of the dissipation of the electrical energy, 1 watt is equal to 1 joule divided by second. How? So this is joule, electric potential energy. This is time. 1 joule per second is equal to 1 watt. But this equation, which is P is equal to I times delta V, can be written in two different forms. So one of them is, instead of delta V from the Ohm's law, you can write I times R, so it becomes I squared times R. So another form of the power equation is I squared times R. This is also most frequently used in physics next year. Another one is, instead of I, you can write V delta V over R. This is I. So then delta V times delta V becomes delta V squared divided by R. This is third form or second form of this equation. But all these two are not different equations coming from this one. Only we use Ohm's law and rewrite the equation and we get them. So now, as I said, this is in the 12th grade, you are going to get so many questions about the power. So this is the ministry exam questions, 2015 and 16. An electric heater operates under an alternating potential difference of effective value 200 volt. So delta V is 200 volt. If the resistance of the heater is 500 ohm, resistance is 500 ohm. Calculate the generated heat energy. If the current runs in the heater for half an hour, calculate the generated heat energy. If the current, sorry, this is not 3 point. This is not accurate, yes. If the current runs in a heater for half an hour means 0.5 hour, but we must convert this to second. How? By multiplying 3600. Why is it like this? Because 1 hour is 3600. You should know them, they are very important. So power is equal to change electric potential energy divided by delta T. If we cross multiply them, so change electric potential energy becomes P times delta T. And what is P equal? Delta V over V square over R. Now, first we calculate delta T as 1800. Then delta V is 200 squared divided by R is 500 multiplied by 1800. Answer becomes 144,000 joule. So electric energy given out by converted to heat is 144,000 joule or 144 kilojoule. All right, so this is the next and the last title of this chapter. It is the circuits, electric circuits, schematic diagrams, and the circuits. A diagram that depicts the construction of electrical apparatus is called a schematic diagram. So it is a schematic diagram of this one. Here is a bulb. Here is a lamp, battery. Here is a switch. So when you cannot always draw this picture. That's why you should draw something simple. So by symbols. So that the drawing, which includes the symbol of this device, is called schematic diagram. So symbols are in electricity is this. Wire can be symbolized by straight line. Resistors are load by this symbol, which is resistor R. Lamp is by that one. Plug is by that one. So battery has one positive, one negative end. Positive end is high electric potential. Negative end is low electric potential. So this is the battery. This is the switch, open switch, close switch, and capacitor. This is the capacitor. So these are the devices which will be drawn in schematic diagram. So when you connect when a wire connects the terminals of the battery to the light bulb, as shown here, the charges on one terminal of the battery have a path to follow to reach the other terminal of the battery. So from one terminal to other terminal, other end, the charge is moving. Because there are charges moving through the wire, the current exists. This current causes the filament to heat up and they glow. Together, the bulb, battery, switch, and wire form an electric circuit. All together, they form an electric circuit. Electric circuit is a path through which the charge can flow. A schematic diagram for a circuit is sometimes called a circuit diagram. Any element or group of elements in a circuit that dissipates energy is called load. Now, here is the load, here is the bulb, and this is the battery, this is the switch, this is the bulb. So now when you connect this circuit, electric current will start from positive, will pass through the bulb, come to negative, and it's called as closed circuit. If electric current is able to move, so it's a closed circuit. But if you open the switch, electric current cannot move. So that is called the open circuit. So this is an open circuit, as you see. Electric current is not able to move from positive to negative because here it is open. Now, resistors are very important devices. I said generally resistors are used to increase electric current or decrease electric current. For example, two light bulbs are connected in series. What does series connection mean? If electric current starts from positive, pass through the resistance wire 1, and the same current also passes through the resistance 2 and comes to negative terminal. So these two resistors are said to be in series. So if the same electric current passes through from the resistor 1 and resistor 2, maybe resistor 3, without splitting into branches, so this is called, these resistors are called to be in connection in series. So in series connections, electric currents are equal. That is the very important point. Why? The same amount of charge flows through R1 and also R2. In series connection, electric currents are equal. But if this battery is 3 volt, these bulbs share this potential difference. Assume they are identical bulbs. If the battery is 3 volt, these bulbs share the electric potential difference, 1.5 volt here, 1.5 volt there. So then we can say that electric potential difference across a series connected resistors, one of them is delta V1, the other one is delta V2, and delta V is the battery's electric potential. So we are going to add them to find the total potential difference. So total potential difference in a series connected resistor is what? Delta V1 is the potential difference on the first resistor. Delta V2 is the potential difference on the second resistor. Delta V is the potential difference of the battery. So sum of these two will give us the potential difference of the battery. This is one of the most important thing in resistors in series. Second one is, when many resistors are connected in series, the current in each resistor is the same. This is another important thing in resistors in series. If we apply the Ohm's law, remember delta V is equal to delta V1 plus delta V2. Delta V1, because currents are the same, I wrote here, I times R1 delta V1, I times R2 delta V2. I times R1 plus R2 is delta V. If I simplify, you are going to get equivalent resistance of this circuit. What does equivalent resistance mean? Instead of these two resistors, you are going to draw in the schematic diagram only one resistance. So this resistance is known as equivalent resistance, and we can find this equivalent resistance by adding them. R1 plus R2 is equal to R equivalent. If a third one, R3. If a fourth one, R4, and so on. Okay, a question. It says a series combination of two resistors one of them is 725 ohm, the other one is 4.03 ohm, is connected to a 9 volt battery. So let's draw the picture. R1, R2, they are in series, connected to a battery of 9 volt. This is R1, this is R2, this is delta V, that is the battery, negative and positive terminal. So calculate the equivalent resistance of the circuit and the current. Equivalent resistance can be calculated because they are in series, you are going to add them to find equivalent resistance. 7.25 plus 4.03, it becomes 11.84. Now we can calculate the electric current because now we make the circuit like this. There is one battery, delta V, and there is an equivalent resistance delta. Now apply the Ohm's law for finding the electric current. Electric current is equal to potential difference divided by resistance, equivalent resistance. So potential difference is 9. Equivalent resistance we calculate 11.38, which is equal to 0.79. Part B. What is the potential difference across each resistor? Now, general student does mistake here. When they calculate the electric current, they are just writing one of the resistors number here. So delta V over, they are writing 7.25 or 4.03. You cannot do that because the electric current is passing through not only from R1, not only from R2, from R1 and to both R1 and R2. For that reason, you should calculate the equivalent resistance. Then you can calculate by the electric current by applying the Ohm's law. However, now we are going to calculate the potential difference across the resistance V1 and potential difference across the resistor V2. R2, sorry. So delta V1 is equal to, now because electric current is the same passing through each resistor, the same electric current will be multiplied by R1 and we will calculate potential difference across resistance 1. So 0.79 is the electric current. What is R1? R1 is given 7.25. If you multiply these two numbers, you will get the potential difference across the resistor 1. Then potential difference across the resistor 2 is I times R2. I is the same, again the same current is flowing through, passing through the resistor 2. Resistor 2 is 4.803 ohm. When you multiply them, you will get the potential difference 3.18. When you add these two potential difference, delta V1 plus delta 2, you are going to get delta V, which is equal to 9 volt. What is 9 volt? 9 volt is the potential difference of the battery. Now, there are also, we can solve so many problems, but I'm not going to continue them. This is one of the 12th grade question about the resistance series. That's why I see it and learn this title very best, because next year we are going to meet again resistors connected in series. Now, resistors connected in parallel. How can we understand two resistors are connected in parallel? If an electric current starts from positive terminal and comes to a point, at this point if it splits into two, we can say that these resistors are in parallel. So electric current passing through the first one is I1, electric current passing through the second resistor is I2, electric current of the circuit is I. So in parallel combination, this electric current splits into two. For that reason, I is the electric current that the circuit will be electric current on the first resistor plus electric current on the second resistor. This is one of the property of resistors in parallel. Second property is this. Because this point and this point and this point all have the same electric potential, these and this and this, they have the same electric potential. Potential differences across the parallel connected resistors will be equal. Potential difference on R1 will be equal potential difference on R2 will be equal to potential difference across the terminal of the battery. So in general, we can say that potential difference between the terminals of parallel connected resistors are equal. So how can we calculate the equivalent resistance? Very easy. We are going to use these two things. One of them is total current of the circuit is equal to current on the first resistor plus current on the second resistor. And we know that potential difference of the battery is equal to potential difference across R resistor 1 and potential difference across resistor 2. So delta V over R equivalent is I. Delta V over R1, I1. Delta V over R2, I2. So this delta V simplify, you get the equation for calculating resistance which of the resistor, equivalent resistance of the resistor which are connected in parallel. 1 over R1 plus 1 over R2 is equal to 1 over R equivalent. A question. And 18 ohm, 9 ohm, 6 ohm resistors are connected in parallel. 3 resistors are connected in parallel to an EMF source. What does EMF source mean? It is a battery. So a current of 4 ampere is in 9 ohm resistor. So now let's draw the picture. There are 3 resistors. Let me draw them. One of them is 18 ohm. Second one is 9 ohm. Third one is 6 ohm. All they are connected in parallel across the terminal of a battery. So question says that 4 ampere current passes through the 9 ohm resistor. Now, what is the potential difference across the source? Because they are connected in parallel, potential difference across the source will be equal to potential difference across 6 ohm, will be equal to potential difference across 9 ohm, will be equal to potential difference across 18 ohm. So now, by using Ohm's law, I can calculate delta V and the potential difference across the 9 ohm resistor. I is equal to delta V over R, delta V is equal to I times R. I is equal to 4 ampere. Resistance is 9 volt, which is the resistance of this one. So multiplication is 36. So potential difference across each resistor and including the battery itself is 36 volt. Calculate the current in the other resistors. So then we know what is potential difference here is. It is 36. Here is also 36. Now we are going to use the Ohm's law again. I1 is delta V over R1. I3 is delta V over I3. So delta V 36 we calculated both for both of them. So R1 is 18 ohm. So I'm going to write here 18. We will get the current on the 18 ohm resistor, which is 2 ampere. So third one is 36 divided by it will be 6. Yes. In this case, 36 divided by 6, it is the 6 ampere. So here is the electric current is 6 ampere on the 6 ohm resistor. Again, you are going to meet the resistance in parallel in the 12th grade, so you shouldn't forget this title until the next year.